Lesson 4 is on the primary trig ratios for any angle. In the last lesson, we looked at angles on the xy plane, and we discovered that we can find angles of any size, positive or negative. We were looking at coterminal angles in the last lesson. Consider the following. So we're going to look at quadrants of the Cartesian plane. A point P, xy, so we have this point P here, is on the terminal arm of angle theta. So we have this angle theta here. We can create a right-angled triangle by dropping a perpendicular line from the point PXY down to the x-axis, and we're going to call that point D. What I want you to notice is the length of this side of the triangle would be x, and the length of this side of the triangle would be y, because this is our vertical measurement. So if this point was 3, 5, for example, this would be a distance of 3, and this would be a distance of 5. To find the hypotenuse here, we're going to need to use the Pythagorean theorem, and it'll just be the square root of x squared plus y squared would give you r squared. So again, something interesting to notice is that we can use our primary trigonometric ratios again, but we're really relating it to a Cartesian plane. So the sine of theta would be opposite over hypotenuse, or y over r. The cosine is adjacent over hypotenuse, so x over r. And the tangent is opposite over adjacent, so we've got y over x. So something that I'm going to write down, this is a little tedious, but I want to show you sine theta, cos theta, tan theta for each of these angles. So this is something you've done before. Rounding to 4 decimal places, I want to know what the sine of 62 is, the cos of 62, the tangent of 62, using a calculator. So you can do it too, but I will write these out. So I was just using my calculator and typing all of these in: sine 135, cos 135, tan 135. What I want you to do is just take a second and look at all of these numbers. Some of them are negative. You're getting some negative answers on your calculator, and some of them are positive. Some of them repeat though. So for example, here's the tangent of 62 is positive 1.8807. Look at there, there's another negative 1.8807. Those are the same value. Those are not coterminal angles because they don't differ by 360 degrees. These are different angles, but they're giving us the same numbers, except this one's negative, for our ratios. Look at these two. There we go. Negative 1.4281, positive. Here's another one that's the same. Sometimes we actually have the exact same value. So why would the cosine of 135 be the same as the cosine of 225? But I wanted you to just notice how many repeating numbers you're seeing here on this table. Some are positive, some are negative. And why is this happening? So the question is, how are the values and the sign related? How come some are positive and some are negative? To answer this question, we need to look at our Cartesian plane. So let's look at a simple right triangle on a Cartesian plane. One thing I want you to know first, we do have quadrants. This is quadrant 1 and 2 and 3, which you might remember, and 4. So our quadrants, so everything is positive in this first quadrant, right? If we go over x and up y, this point is maybe like 3, 5, or whatever it is. Those two values are both positive. If we're looking at the point over here, this value for x is negative and the y is positive. If we look at quadrant 3, the x is negative and the y is negative. So this might be point -3, -5. And over here, we have a positive x but a negative y. So those are all slightly different, right? All of the quadrants are giving you different values that are positive and different values that are negative. So let's just look at the first quadrant over here. We'll start here. Sine theta, opposite over hypotenuse. So we have y over r. Cos theta, adjacent over hypotenuse. So we have x over r. Theta is opposite over adjacent, so that would be y over x. all of those values end up being positive in the first quadrant. Let's look at over here, the second quadrant. If I did sine theta opposite over hypotenuse, that's y over r. And adjacent over hypotenuse, that's negative x over r. And tangent is y over negative x. All right, so I'm seeing that the sign was positive there, but the other two were negative. If I look at quadrant 3, everything is negative. So if I'm standing here, sine is opposite over hypotenuse, that's negative y over r. Cosine is adjacent over hypotenuse, so that's negative x over r. And tangent is opposite over adjacent over negative x, which would actually just give us y over x. So they were negative values that we used, but the tangent actually ends up being positive in quadrant 3. When we look over at this one, the sine is, if I'm standing up here, opposite over hypotenuse, negative y over r. Cosine adjacent over hypotenuse is x over r. And the tangent is opposite over adjacent, so that's negative y over x. So when I look at that one, the cosine was positive, but the other two were negative. So there is something called the cast rule. So what I notice here, this is positive here. All of these are positive, right? We had 3 values that are positive here. The only one that was positive here was sine, and the only one that was positive here was the tangent. So the cast rule, C for cos, this one down here is cos is positive. In this quadrant here, all are positive, so A for all. S, the sine is positive in this quadrant, and T, the tangent is positive here. So that's the cast rule. So cast rule, it's a little bit tricky because this is quadrant 1, and we always start our quadrant counting up here in the top right, but the cast rule starts down here. So C-A-S-T, cosine's positive, all are positive, sine is positive, tangent's positive. So rules to find the second angle that would have the same ratio. If we want the angles to be in between 0 and 360, what we do for the sine ratio, we would take 180 minus theta. So if I had an angle in the first quadrant, I know sine is positive. If I do 180 minus that angle, the sine will also be positive in that quadrant. Tangent, if I had an angle where tangent was positive up here, if I did 180 plus that angle, my angle would be over here, and tangent would also be positive in that quadrant. For the cosine ratio, I'm going to take 360 minus theta. So I have an angle up here that is positive for cosine, and if I do 360 minus that angle, my angle will be over here, which will also be positive for cosine. So this is something that you might have to point out or highlight and try and remember these for some of the questions that we'll do. So we'll come back to that, but example 2, theta is an angle in standard position. We have this point up here that is negative 815. So the diagram would help. If it doesn't have a diagram, you might want to draw one. Determine the primary trigonometric ratios of theta. So interestingly enough, we don't actually know what the hypotenuse is. So we're going to have to find r. We need to know what that is before we start. So I end up getting the hypotenuse is 17. So if we're going to write the primary trigonometric ratios for theta, we're going to do sine theta. This is my angle of reference. Opposite over hypotenuse, that's 15 over 17. Cos theta, if that's my angle of reference here, adjacent over hypotenuse, so negative 8 over 17, and I can get decimals if I want to divide those on my calculator. And then tan theta is opposite over adjacent, so 15 over negative 8. What I want you to notice is that sine is the only one that is positive. So C-A-S, sine should be positive in this quadrant, and the other two should be negative. Okay, example 3, given tan alpha equals 15 over 8. If we didn't have a diagram, what you need to know is if we have an angle theta, tan is positive in this quadrant. So CAST, tan is positive over here. We have opposite over adjacent. So opposite would be 15 and adjacent would be 8. To get this point though, we'd have to have negative 8 and negative 15. We're going to have to find our hypotenuse again, and it would give us a measurement of 17 again. So what we're asked to do is to determine sine alpha. So just sine alpha in this question would be, this is my angle of reference, so opposite over hypotenuse, negative 15 over 17. And I think CAST, sine, should be negative in that quadrant. Example 4, determine two angles to the nearest degree between 0 and 360 associated with each of the following. So in between 0 and 360, what we're going to need for this question is to go back to this little rule here that we have. So 180 minus theta for sine, and tangent 180 plus and 360 minus theta for cosine. So I just wrote them down up here. In order to find a second angle, first of all, let's find out what this angle is. So theta would be the inverse sine of 0.159, which actually gives us 9 degrees. So let's call that our first angle. In order to find our second angle, we're going to do 180 minus 9, and we get 171. So if you type in sine of 9 or sine of 171, they should both give you 0.159. And this should make some sense because if I have the sine of 9, 9 is not a very big angle, CA, all of my ratios are positive in this quadrant, so sine should be a positive number. And then if I do 171, I'm also over here, and CAS, sine, would also be positive in that quadrant. So tan theta equals 5.23. Let's find angle theta then. And the inverse tan of 5.23 gives us 79 degrees. So to find a second angle that would also give us that same value of 5.23, I'm going to look up at my rules 180 plus my angle. So 180 plus 79 will give me 259 degrees. So if I type in tan 259, I should get 5.23. If I type in tan 79, I should get the same thing, which hopefully makes sense. If we think about 79 degrees would be somewhere over here, and all ratios are positive in that quadrant. And then if I add 180 to it, I'm going to end up being down here, and CAST, tangent's also positive in that quadrant. So we would get the exact same value for those two angles. The last one, let's find the angle first. The inverse cosine of negative 0.513 is 121 degrees. So if I type in the cosine of 121 degrees, I get a negative 0.513. If we imagine that first, 121 is somewhere over here. If that's 90, that's 121. So CAS, the only thing positive in this quadrant is sine. So I get a negative 0.513. Another quadrant where I could also get a negative value for cosine, CA, so positive, positive for cos, but these two quadrants are negative. So if I do 360 minus 121, so I'm looking up here at my rule, I get 239 degrees.